Hello students, welcome back. Myself Manjunath ji. So today I'll be solving several problems on stress and strains topic, strength of materials. Okay, so the question goes something like this. Okay, an alloy bar 1 meter long and 20 mm by 10 mm in cross section is subjected to a subjected to a subjected to a compressive load of 20 kilonewton. If the modulus of elasticity for the alloy is 100 GPa, find the decrease in the length of the bar. There is the question, friends. So we try to solve it. Okay. How do we solve this? So we say what is given? Length. The strength of metal, so we'll take everything in terms of mm. So 1 meter. 1 meter is, you know that it is equal to 1000 mm. Then what else is given? Area cross section capital A equals 20 mm by 10 mm. 20 into 10 is 200 mm square. Area of cross section. Area of cross section. Then what else is given, students? The compressive load. So P, capital P equals 20 kilonewton. That is equal to 20 into 10 power 3 Newton. Is it clear, students? Then modulus of elasticity, capital E equals 100 gigapascal. Now very important, students, exactly 100. 1 gigapascal is 10 power 9. 10 per meter square is 1 pascal. So that is equal to actually 100 into 10 power 9 by 10 power 6 is Newton per mm square. So this is very important, students. So 1 megapascals is 1 Newton per mm square. How it is, I'll tell you. 1 into 10 power 6 Newton per meter square. So that is actually 10 power 6 Newton per 1 meter is 1000 mm. 1000 into 1000 is 10 power 6 mm square. So directly I wrote, it will get cancelled. So 1 MPa is 10 1 Newton per mm square. So I'll just have to write into 10 power 9. So if I divide this by 10 power here 10 power 6 mm square. So this becomes 10 power 9 minus 10 power 6, which is 100 into 10 power 3 Newton per mm square. Okay, students. So make a note of this. It's very, very important. Students usually make mistakes with this, so be very careful with this. The conversion factor. Okay, students. Then what do we have? Okay, so that is capital E is 100 into 10 power 3, 100 into 10 power 3 into mm square. Okay, now what else we have to do? So we have to just find the decrease in length. So given to find. So this is actually student. This was our given. So to find next, how to find it? So we have delta L equals PL upon AE. So that will be equal to, what is that student? This is the formula. So P, capital P is 20 into 10 power 3 into small l is 1000. So right, it is 10 power 3 upon capital A is 200. So the unit student, load should be in newtons and length should be in mm and area should be in mm square and modulus of velocity should also be in newton per mm square. So into 10 power 3, 10 power 3 into 10 100 is 10 power 5 and write directly 10 power 5. So that will be delta L equals 20 into 10 power 6 upon 200 into 10 power 5. So we get the answer as 2200 into 10 power 5 upon this 0. If I shift here, this reduces 200 into 10 power 5 upon 200 into 10 power 5, which is everything get cancelled. So we have delta E equals 1 mm squared. That is the required decrease in the length of the bar. Okay, students, if you have any doubt, you let me know. Okay, in the comment section, we'll move on. The next question. Next question we have. Okay, next question is, yeah, a straight bar of 500 mm length as its cross section area of 500 mm square. Find the magnitude of the compressive load under which it will decrease its length by 0.2 mm. Take capital E for the material, bar material, as 200 the Pascal. Very simple, students. How to proceed for this? So just write the given. What is given, students? Length of the bar, capital L equals 500 mm cross section area capital A equals 500 mm square. So we have to find the load P. So equals question mark. So we'll just write that as P and we'll write this as L, that is delta L, which is in length 0.2 mm, and capital E equals 200 gigapascals. Now given to find capital P. So this one we forgot to convert the student. Very, very important. So capital E equals 200 into 10 power 9 Newton per meter square. So capital E equals 200 into 10 power 9 by 10 power 6 Newton per mm square. So that is capital E equals 200 into 10 power 3 9 is 3 Newton per mm square. The Young's modulus of the steel. So to find capital P. So how do you proceed, student? So as usual, you want to find a solution. Solution is the formula with delta L equals PL upon A. So just go for substitution, students. What do we get? This will be capital P is, that's what is unknown. So delta L is 0.2 is equal to capital P into small l is 500 upon capital area is 500 and capital E is 200 or 2 into 10 power 5, but 200 into 10 power 3 is 2 into 10 power 5. So this is very simple, students. So we have used all the data. So what we'll do, we just cross multiply 0.2 into 500 into 2 into 10 power 5 equals 500 into P. So our P is 0.2 into 2 into 10 power 5 into 500 by 500. So 500 cancels. So capital P is how much, right? 0.2 into 0.2 is 0.4 into 10 power 5. It is newtons exactly 4 into 10 power 4 or 400 kilonewton, we can say. 4 into 10 power 4. So this is 0.4 into 10 power 5. So if I shift this 1.4 into 10 power 4. So 4 into 10 power 4, you can write or 400 into or 40. This one we can say 0.4 into 10 power 5. I'll use the calculator for that, friends. So just write 0.4 into 5 into 5. That is 40,000 directly. I'll write. So 40 into 10 power 3 kilonewton. I'll write as. So this can be done directly as 40 kilo. Is it clear, friends? So capital P is 40 kilonewton. So if there is any doubt, don't forget to comment in the comment section. Next, we move on. Next question. Problem 3. That is a brass rod 1.5 mm, 1.5 meters long, sorry, 1.5 meters long and 20 mm diameter was found to deform 1.9 mm under a tensile load of 40 kilonewton. Calculate modulus of elastic after all. Okay, students, so how do we do this? So this will be, yeah, so brass rod, so length capital L equals 1.5 meters, which is 1.5 into 1000. So how much is that, students? So 1.5 into 10 is 15 and double zeros mm. Then we have D is 20 mm. D form delta L is 1.9 mm. Load capital P is 40 kilonewton, which is 40 into 10 power 3 newton. So given to find capital E. So how do we proceed? So solution will be delta L equals PL for AE. So this will be delta L is 1.9 equals capital P is 40 into 10.3 into L is 1500 by area capital E. Area is pi d square by 4 into E, because area circular cross section dia. So capital A you can write directly pi d square by 4. So that will be pi by 4 into 20 square. So I'll use the calculator, students. I'm using 100 ms text. So shift pi into 20 square. The value would be 1256.637. I'll go through rounding to 3 digits. So up divided by 4 will be 256.637 upon 4 is 314. 314.159. So this will be here 1.9 equals 4, 4 into 10 power 4. This I shifted to 0 into 15 into 10 power 2. This 2 zeros upon 5 d square before. Directly I'll write that value 314. This is actually mm square 314.159 into capital E. So this E will be 4 into 15 into 10 power, this is 10 power 4 into 10 power 2 is 10 power 6 upon this is 1.9 into 314.159. So that will be 4 into 15 into 6. Okay, that will be 60 into 10 power 6. So capital E is 60 into 10 power 6 upon 1.9. We just calculated the numerator separately and denominator separately. 3.4.159. Diameter will be 596.902. So that will be 60. 96.902 will be 100, 100, 100.5 into 10 power 3 Newton per mm square. So I get the value as, this is very important, students. So I'm writing that 100.5 into 10 power 3 Newton per mm square. If I want to express in terms of gigapascals, so what do I have to do, students? I have to just write this as, so this is into 10 power 6 by 10 power 6. So this will be 10 power 9, 100.5 into 10 power 9 Newton per and meter square. So that is actually 100.5 giga required root of Young's modulus. Okay, students, as usual again, just point out to pause the video and ask me. Okay, next, we'll move on to the next problem. This problem number 4. Okay. Okay, students. Take rod of cross-sectional area 20 by 20 mm. 20 mm. And one more thing, students, one problem can solve using different methods and different approach. So I'm going with the easiest approach. And the long subjected to compressive load on 40 kilonewton, the modulus of elasticity for steam may be taken as 200 kilonewton per mm cube. Sorry, this is 200 mm square. It's a mistake. Find them. It can't be mm cube. Find stress, strain, and decrease in length of the bar. Due to the applied load. Okay, so what I'll do, okay, so I spread the board so that it's easy for you, students. Okay, the approach goes something like this. The first part, then second, then third. So given, what is given, students? Capital A, area equals 20 mm by 20 mm. So that is 20 into 20. Those are 4 double zeros, mm square. Then L, capital L equals 1 meter equals 1000 mm. Load capital P equals 40 kilonewton 40 into 10 power 3 Newton. Modulus of velocity is capital E equals 200 into 10 power 3 Newton per mm square. So now given to find stress, that is sigma, strain, that is epsilon, and decrease in length, which is delta L. How to proceed with solution? Stress is equal to force by area or load by area. So load is 40 into 10 power 3. Area is, I think, capital A equals 5d square by 4. Yeah. Here it is not circular cross section because diameter is not given. So area capital A, he has given the area we need to find. So that is again equals 20 into 20, so that is 400 mm square. So that will be sigma equals, this is 400 into 10 square by 400. So sigma is our 400 and 400 cancel, 10 square Newton per mm square. So sigma is 100 megapascals. Sigma is 100 megapascals, or 100 Newton per mm square is also fine. So we keep this like that. So yes, that is our sigma. Then we move on to finding strain. Strain is delta L, sorry, epsilon, the extension. So epsilon equals delta L change in length by original length. So delta L is, we have delta L, we are supposed to find original length is, we have to, for that what we have to, we have to find the Young's modulus. Young's modulus is equal to stress by strain. Directly you can find. So Young's modulus is 1. We can use this when delta L was known. So if delta L is not known, so we are supposed to use stress Young's modulus is equal to by epsilon. So this is epsilon equal to directly sigma by capital E. So that is now only we found 100 by E is 200 into 10 power 3. So epsilon is 2. So 1 by 2 is 0.5 into 10 power minus 3. So it has got no units. Then that is your strength, strain. Then we have the stress. Finally, we are supposed to find delta L here. So let's L. So this is 0.5 into 10 power minus 3 into capital small L is 1000 10 power 3, which is 10 power 3 and minus 3 cancel. I'm using epsilon into L equals delta L, which is 0.5. So it is over delta L. Delta L is 0.5. And okay, students. Okay, students. Just go through this. Let's go through this. Let's solve one more. So, yes, have any doubt? Let me know. I'll come up with a few more topics. So till then, don't forget to like, share, comment, and subscribe my channel. Matthew, like and I also want to comment so that if you need to change so something anything kind of I'm always subjected to very much interested to know. So like it, share it to the maximum. Sharing and one more important is what is important is comment and share it to the maximum students so that help me to do more problems. Any where if any problems, any step is not there. Thank you. Take care.